Okay guys, so what we're going to have a look at now, standard deviation. Let's see what's going on here. Yeah. There we go. Right. So I'm going to give you two sets of numbers, and I'd like you to calculate the average, of the mean average of both. So the first set -5, 0, and 5, and then the second set -100, 0, and 100. Dude, what are you doing shove across the classroom while I'm teaching? Joshua? Right, so give me the two averages here, please. Yeah. The first one will have average of 0. The second one will have average of 0. So we'll have in the first one, its average is 0. And in the second one, its average is 0. And the reason I'm doing this example is to show you that average by itself is not enough of a statistic. It doesn't really give you enough information about the data. I mean, it's good that we know that 0 is the average in both, but you can see a big difference between the first and the second. How would you describe the difference between the first and the second? Yeah, go ahead, Daniel. Yeah. Say again?
One of them is bigger than the other.
Well, yeah, but what exactly do we mean by bigger here?
It means one of them is 3.
Yeah, we're getting closer now. So you're looking at how far out the numbers go.
Yes.
So in the first one, they go from -5 to 5. And in the second one, they go from -100 to 100. So now we need to look at something which tells us what's called the spread of the data. How wide the data is, how far out it spreads. Okay, and that's what this lesson, the title means, standard deviation. Standard deviation is a way to measure how wide the data is. So I'll give you the formula, and we'll do an example of calculating it. So the formula for standard deviation, and remember, I'm saying standard deviation tells us how wide the data is. So we think this one should be wider than this one. So for standard deviation, what we do, it's square root, and then first we calculate the average minus how far the point is from the average, square it, and then divide by how many points of data we have. So we'll do an example. So let's say our data is 1, 2, and 3. So the average here is 1 plus 2 plus 3 over 3, which equals 2. Yep. Yes, I'll get to that in a minute.
What's
xi, these are, just to be clear, xi is each point of data. So this is x1, this is x2, this is x3. So that will go in here in the formula. And then this here is the average, which I've just worked out is there. And what would the n be in this example? 3. So let's calculate it. Square root. So what we do is we do 2, I'll do it in red here, the average minus the data, the average minus the data squared plus the average minus the next piece of data squared plus the average minus the next piece of data squared all over 3. So the 2 in red is the average, and then in green is all the data. So simplifying, this would be 1 plus 0 plus 1 over 3. So this would be square root 2 over 3, which is, what's that, about 0.81 or something like that. Can you type that in, please? What is it? Not bad at all. 0.816. What? I was accurate to 2 places of decimal in my head.
Yeah, that was my question.
What? How? I've got skills.
Did you just remember that?
Yeah, from last year, like 365 days ago. Now, what I want to talk about now is what exactly does this result mean? So we have an idea in our head about what the average means. When we think about average, we kind of think about a point that's like in the middle of our data. So what exactly does this mean, 0.816? Well, let's have a look at the data again. So we have our 3 points, 1, 2, and 3. And what's the average here? It's 2. So in this example, it's nice that the average is also one of the points in the data set, but doesn't have to be. How far away is this number from the average? 1. How far away is that from the average? How many units away is it from the average? It's 1 unit away. And how far away is this? 0. And how far away is this? 1. So can you understand that these numbers here, it's like the distance the data is from the average. Now what's the average of these numbers? What's the average of these numbers? Add them and divide by 3. So 0.67. So it's not so clear in this example, but there's not a big difference between this number here and this number here. And that's what I want you to see, that the standard deviation is a bit like the average distance the data is from the average. Now you might say, well, that's not that similar, there's a big difference, you might feel. And that's true. I said standard deviation is like the average distance from the center. It's not exactly the same, but the good news is the more points in your data, the better, or the closer those 2 numbers will be. So if n is big, then the standard deviation, we can think of it as being roughly the average, the mean average from the mean average. It's on average how far away you are from the average. So if you had like 100 points of data, I'd expect the answers to be, the 2 different answers I got here to be very, very similar. Now, as Joshua was saying, there is another formula for standard deviation which I want to show you what it is. And the other formula is a little bit easier to use, it's a little bit easier to calculate. So just before I calculate, I want to show you 2 notations here. When I write this, this also means the mean average. It's just a different symbol, that's all. So for example, in this case here, what was it? 2, wasn't it? When I write this, it means the average squared, so in this case here it's 4. But please be careful, when I write this, it is not the same thing as that. This here means square the data and then find the average, whereas this one here means find the average from the data and square it. So I need to say that again, because there will be people who mix it up. First, find the average, then square it. And here, first square it, then find the average. So our data was, what was it, 1, 2, 3. If I square that, what do I get? 2, 4, 9. Oh, sorry, too early. 1, 4, 9. So if I add these together and divide by 3, I get 14 over 3, which is, what's that, 4.67, is it? 4.67, alright. Well, 15 over 3 will be 5, so it's 1/3 away from that. 4.67. So see, they're different. And not only are they different, this one is bigger than this one. And that's also something that's always true. So first note that this will be smaller than, could be equal, but it will always be smaller or equal than this one here. And this one here is mean and square. Where this one here is first you square, and then you get the mean. Now the reason I use these symbols rather than the bar previously is because I don't feel the bar is so clear. If you were to use the bar, you would have to write this one as follows, average and then square, whereas this one here will be square then average. And it's not so easy to read that, especially in an exam when you're writing fast. It'd be easy to mix the two up. So that's why I use this notation here for average and square. Okay, so let's go back to our formula. Can I scroll down? Yep. So what we're going to do is try and find a formula, a different way of writing our formula for standard deviation. X average minus xi squared over n. So the first thing I'm going to do is square both sides to get rid of that square root. Squared equals average minus xi squared over n. Now I'm going to bring that n up to the left. Well, no, I can leave it where it is. I don't have to bring it up. So what I'm going to do next is open the brackets here on the right. So you have sum x average. Now I think this is when I'll switch to my bracket so there's no confusion. So this is average squared minus twice average xi minus xi squared over n. So I just square the brackets, but I'm just writing average now this way. Thank you. Okay. So just putting the n on all of these, you have sum average squared over n minus sum twice average xi over n plus sum xi squared over n. Yep. Yeah, I can zoom out a bit. This good? Yeah. Now, I just want to remind you of something here. But suppose you have something like 2 plus 2 plus 2. That would equal the sum of the number 2. So if I did this, let's say n equals 1 to 3, like I have here, there's 3 of them, what answer do I get? What's the answer here? 6. The same, how did you get that? It's 2 multiply 3. Like if I was to do 2 plus 2 plus 2 30 times, what do I get here? 60. I'm just reminding you that when you add the same number to itself many times, you can just do that by multiplication. Now, if you look here, the average is a constant. It's not changing. In fact, in my example, I gave you the average was 2. So this number here does not change. So how many of these numbers do you have? Well, you have n of them, because remember, n is representing how much we have. So this first piece I can write it as just n multiplied the average squared over n. Now, in this second piece, this is a constant. It's a constant in each term that I'm adding, so I can take it out in front. 2 average sum xi over n plus sum xi squared over n. They cancel, that's great. This one here? What's missing?
Like in the first fraction with n before the squared average, right?
Here?
Yeah.
N, yeah, this here?
Yeah, no,
here?
second line.
Here?
First line.
Here?
Yeah, you put n in the numerator, right?
Yeah.
Does we need to do the same with the second fraction?
No, because what I'm doing here is this is a common term that I'm taking out, a bit like this. If I had...
Oh,
okay, yeah, right. Now, if you look here, you'll realize that this here is just the average of x. You add up all the x's, and you divide by how many you have. So that's just average of x. And then what's this one? Well, this one here, you square your data, and then you divide, add it up, and then divide by n. So this last piece is actually the data squared average. So now the things are again much simpler now. This is average squared minus twice average squared plus square then average. So this is minus average squared plus square and average. So we have this result. Standard deviation squared equals the data squared and averaged minus the data averaged then squared. Yes? You can, but I don't remember which formula they have in the formula book. They might even have both actually. But both are fine to use in the exam. Okay, so let's look at an example of calculating standard deviation using this formula and doing it with a frequency table this time. So for example, let's say this is 0 to 2, 3 to 5, 6 to 8, 9 to 11. Yeah. And let's say we have 3 of these, 4 of these, 4 of these, and 2 of these. So it's good with these questions if you can get just a rough idea of what the answer should be before you start. That way in the exam you know if you have an answer that you think could be right. So looking at this set of data, what would you say the average is roughly? Yeah, in fact I would say 5.25 roughly. I don't want to say exactly 5.5, Joshua, because there's a little bit more numbers smaller than 5.5 than there are bigger than 5.5. So I think the average should be a little bit over 5, like 5.25. And what do you think about the standard deviation? Roughly on average, how far away are you from 5.5? Well, these numbers here would be, about 4 away, and these numbers here, would be less away. I don't know, I'm going to say roughly maybe 2 for the standard deviation. So I'm looking for an answer which is a little bit over 5 for the average, and the standard deviation I think will be about 2, something like this. So first let's calculate the average, because we'll need that answer for the standard deviation. Oh yeah, so first we need the midpoint. That will here be 1, 4, 7 and 10. So the average here would be 1 times 3.
Don't we need to extend the class boundaries?
Not in, do we need the class boundaries here?
Yeah. Then it should be from 0 to 2.5 and root of 1 to 1.25.
Yes, well, I know when I extend the class boundaries I'll get the same numbers here, because in this case I can say x will be negative. If you, I'll write the class boundaries in if it'll make you happy. Class boundaries here, x is some number which could be positive or negative, okay, just to be clear. So the class boundaries here, this is 2.5, this is 5.5, this is 8.5, this is 11.5, and because I'm allowing negatives here, this one is minus 0.5, because any number bigger than minus 0.5 will round up to 0. So like for example, minus 0.1 will round up to 0. So the midpoints here now are 1, 4, 7 and 10. Now we're happy, yes? Okay, so average will be 3 plus 16 plus 28 plus 20 all over 3 plus 4 plus 4 plus 2. So that's 20, 28, 48, 48, 51, 67, is it? A over 13. What's that, 5.2 or something? Is it 5.2? 5.21, alright. And what was my estimation? 5.25. So if we were in the exam, we'd be very happy. Very happy.
What if you would put 5.25?
From the start? With no workings? I don't think I'd give you any marks for that. Yes. It's obvious, isn't it? Right. So next we'll need to get the squares. Well, first I'll just get the square of this one. 5.21 squared. And next I'll need to get the squared average. The average in squares, I mean. So what I'll just write here is, these will all become squares now. So instead of 1 it's 1, instead of 4 it's 16, instead of 7 it's 49, and instead of 10 it's 100. So this would be 3 plus 64 plus 196 plus 200. all over 13. Huh? Dude, with a calculator and not knowing how to use it? I'm embarrassed for you. Right, 5.15. Thank you. Yes? What are we talking about? Which one? 3 squared? This here?
Why is this squared?
No, this is 3. You square the 1 and multiply it by 3, but this does not get squared. So it's 1 times 3 is 3, 16 times 4 is 64, 49 times 4 is 196, and 100 times 2 is 200. Yes? Yeah, but that's what I am doing. But I do square x. I don't square f. And I am multiplying by f. Why are we confused? What's the confusion here? No confusion? I have 1, 2, 3, and I have 2 of these, 1 of these, and 2 of these. So if I want the squares now, we're all agreed it would look like this. 1, 4, 9, 2 of these, 1 of these, and 2 of these. Yes? So if I want the average, how many 1s do I have? 2 of them. So 2 times 1. How many 4s do I have? 1 of them. So 1 times 4. And how many 9s do I have? I have 2 of them. So I just multiply the f by the x squared. As you said, which I did. Divide by 5. I'm doing the same thing over here. Yeah? So this is 396, 463 over 13. What's that? Goes in about, I don't know, about 26 times or something. What is that? 46? No, not you. 463 divided by 13, please.
35.6.
35. Are you sure about this?
35.62.
Right. Now we're ready to calculate the standard deviation. The standard deviation would be this number minus this number. So that is 35.62 minus 5.15 squared. So what's that, please? Ali, I can trust you. What is it? Okay. So the standard deviation is roughly 3. What do you get? 3 point what, please? 0 something? Okay, so 3 it is. So it was good to have a rough idea of the answer at the start, because that means if you got an answer of like 6 here, something like 6 should make you feel like you did something wrong. You have to check your calculations. Also, sometimes in the exam, students, I don't know, they make a mistake and this number's negative, and then they can't get a square root of a negative number, so they just drop the minus sign and get the square root anyways. It's impossible. You must not get a negative number here. If this number is negative, you did something wrong. You should check your calculations to make sure you get full marks here. Normally what they do in the exam is, firstly they ask you for the average, and then secondly they'd ask you for the standard deviation. And it's not so bad, like this could be 3 marks and this could be 3 marks. And this would be the first 2 parts of a section B question, possibly.
And put tables above the class boundaries?
They could, they sometimes have. That usually only gets 1 mark. Sometimes they ask you to draw, write in the class boundaries on your table that they give you.
So what do you just do?
What I just did. You have to do it anyways for the calculations. So, I mean, it's just an extra mark. Let's just have a look here. There's an interesting result with average and standard deviation. If I have some data and I know the average, oh, by the way, if we want to use Greek letters, this is the Greek letter for the average. So this is the mean average. And this here is the standard deviation. So if you don't give me data, but you just tell me the average and the standard deviation, so for example in this room you say the average height is 1.6 meters and the standard deviation is 0.1 meters or whatever, I can know that nearly all of the data is in this. So what I'm saying here is if you tell me the average and the standard deviation, I can actually tell you where nearly all of the data will lie between. I know that practically every piece of data you have will be bigger than the average minus 2 standard deviations, but smaller than the average plus 2 standard deviations. So if I give you average is 1.6 meters and standard deviation is 0.1 meters, I know that the data, although I can't see it, I expect it to be between 1.4 meters and 1.8 meters. Now this is just it's not something we're going to do in the course, but it is something useful for when you're doing your lab reports, even just next year as well. The reason you need to say in your report what the average and standard deviation is because it can give the reader a quick way of picturing the data. If you tell me this and this, I know that most of your data is between 1.4 and 1.8. And when we do histograms, I know the biology students have done them already, it also means for your histogram, well that's not a histogram, that most of the data on the histogram will be between 1.4 and 1.8. You probably haven't done standard deviation in biology, no? No. But has Colin talked about the width of the histogram? Huh? Just mentioned it. Well, I'm just telling you now, for the biology students, your histogram tends to be 2 standard deviations to the left, and it goes 2 standard deviations to the right, normally. So we can have a relationship between standard deviation and the histogram, and between the minimum and the maximum. Okay, I'll let you try these for a few minutes and then you probably want to take a break for breakfast. So try these for about 5 minutes or so, okay?